Hey everyone, in this video we're going to be learning how to add and subtract polynomials. So when adding and subtracting, we combine like terms of each polynomial. To find like terms, we identify terms with the same variables raised to the same degrees. So what does that mean? So that means if one term has the variable x raised to the third power, you're going to look at the other polynomials for terms that have x raised to the third power. If you have, let's say, x squared y in your term, so now you have two variables in one term, you're going to look for other terms that have x squared y. Even if it has an x and a y, if the exponents don't match, they're not going to be perfectly like terms. And then what we're going to do once we've identified those like terms is we're going to add their coefficients. And then just a little pointer, when subtracting, don't forget to distribute the negative to each term in the polynomial. That's going to prevent us from making any errors with our signs. So we're going to start with an addition problem. So we have two trinomials here that we're adding together. 5x squared minus 3x plus 19 plus 2x squared plus 6x minus 8. So the first term here is 5x squared. So the variable's x raised to the second power. So I need to look for other terms with the variable x raised to the second power. So this term right here, first term in the second trinomial, 2x squared, variables x raised to the second power. So these two are like terms, so I'll underline them. So now we're going to add their coefficients, so 5 plus 2, that means we're going to have 7x squared. A good way to think of this is imagine we had 5 apples plus 2 apples. That would be 7 apples, right? And we can wrap our head around that. In that problem, the apple is the variable. But now we're just replacing that idea of an apple with x squared, a more complex looking variable, but still the same idea, right? We have all these x squareds and we're combining them. So how many do we have when we're done? The next term is minus 3x. Okay, so variables x raised to the first power. Okay, so we're looking in the second polynomial for any terms with an x variable raised to the first power. And we have one right here, 6x. So if we combine minus 3x plus 6x, we're going to get plus 3x. And then we have a constant term of 19 and a constant term of negative 8. Combining those two terms gives us plus 11. So the sum of these two trinomials is 7x squared plus 3x plus 11. Now let's look at a subtraction problem. Two trinomials again, 4x squared plus x minus 10 minus x squared plus 2x minus 6. So the first thing we're going to do is we're going to distribute the negative. So it's going to give us 4x squared plus x minus 10. Now, since we're distributing the negative 1 to each term in the trinomial, this is going to turn into an addition sign. And the way to think about that is understanding that subtraction is nothing more than addition of a negative number. So we're really turning this into an addition problem. Makes our life a little bit easier. And what are we adding? Well, distributing that negative 1 to each term, we'd have negative x squared minus 2x plus 6. Now, we do the same thing that we did in the example above. So we have variable x raised to the power 2. So we look for other terms that have x raised to the second power. So we have 4x squared and negative x squared. Combining those two gives us 3x squared plus x, and then minus 2x is going to be minus x, and then a constant term of negative 10 and a constant term of plus 6 is going to combine and give us minus 4. And there we have the difference of the two original trinomials. Now, in this first example, I underline the first two like terms. Feel free to keep doing that, right? Maybe you'll use a squiggly line. Maybe you'll circle a couple of like terms, square, triangles. Okay, so feel free to use that technique throughout the whole problem, not just for the first set of like terms. Now looking at a little bit more complex example, we have a trinomial added to two binomials. So we have x squared plus 5x plus 1 minus 2 times the quantity 3x minus 1 plus the quantity x squared plus 7. Okay, so the first thing that I want to do is take this negative 2 and distribute it to each term in that middle binomial. That's going to turn this into an addition between the two first polynomials. So x squared plus 5x plus 1. Then we're going to get plus negative 6x and then plus 2. And then we'll have plus x squared plus 7. So in this example, I'll mark it up by identifying the like terms. Okay, so first we have an x squared. So we need to look for any other term that has an x squared. Okay, no, all right here. So combining those two like terms gives us 2x squared. Next, we have a 5x. Okay, looking for like terms, we have a negative 6x, and that's going to be it. Combining those two like terms, going to be minus x. And then lastly, we have a constant term of plus 1, a constant term of plus 2, a constant term of plus 7. Combining all three constant terms gives us plus 10. And there we have the simplification of our original problem. Now, throwing a little bit of a word problem at us, subtract 2x squared minus 4x plus 9 from x squared plus 7x plus 11. The key to this problem is going to be setting it up correctly. If we're subtracting this from this, then this polynomial needs to be written first. So algebraically, this is going to look like x squared plus 7x plus 11 minus the polynomial 2x squared minus 4x plus 9. And especially because it's a subtraction problem, going to be really important that we keep each polynomial inside a set of parentheses. Now our first step is going to be distributing that negative 1 to each term of the trinomial. So that's going to give us x squared plus 7x plus 11. And then we have plus minus 2x squared plus 4x minus 9. Now, we're looking to identify our like terms and combine them. So we have an x squared and negative 2x squared. So that's going to be negative x squared. We have plus 7x plus 4x plus 11x. And then constant terms, we have plus 11 minus 9 is going to be plus 2. And there we have our final answer. Now, instead of doing more examples like this, going through the mechanics, I want to walk through a couple of theory-like questions to get you thinking about what we're doing. So the first question, if we add two polynomials together, is the result going to be another polynomial? So let's start at the simplest type of polynomials. Let's just write two numbers, 2 plus 3. Well, we should know that's 5. 2 is a polynomial, 3 is a polynomial, 5 is a polynomial. So the answer here should be yes. Right? And we can even create a more difficult example. We could say x squared plus 2x and then plus 2x squared minus 3. Right? Combining our like terms, we have 3x squared plus 2x minus 3. Okay, so really any polynomial that you choose, we add it to another polynomial, we're still going to get a polynomial. Okay, in math, we call that a closed set. Right? Every operation still gives us something in that set. Now, what about the difference of two polynomials? Well, if we understand that subtraction is really just addition of a negative number or a negative polynomial, well, then we should have no issues still. Right? The answer would still be yes. An example that might be interesting to look at, though, let's say I had x squared plus negative x squared. Right? That is the difference. I could have written that as just straight subtraction. That's going to give us 0. Right? When we combine those like terms, they're going to simplify each other. And we're just going to be left with 0. So we had a degree 2 polynomial added to a degree 2 polynomial. and we got a constant, which is a degree 0, right? No variable. But what we have to understand, 0 is a number is a polynomial, so we're still good. Now let's take this a step further. If we add a degree 4 polynomial to a degree 3 polynomial, what will the degree of the sum be? So let's start with the simplest degree 4 and degree 3 polynomial that we can create. So that's going to be x to the 4th plus x cubed. Now if we notice, there are no like terms for us to combine, so that's going to be the resulting polynomial. Figuring out the degree of that polynomial, we look at the degree of each monomial term. So the degree of the first term is 4, the degree of the second term is 3, which means the degree of the resulting polynomial is going to be 4. So degree of 4. So in general, if we're adding two polynomials, where one polynomial has a higher degree than the other, the resulting polynomial is going to have whatever that highest degree is. So if I look at a more complex example, so let's say I have x to the 4th plus 2x squared minus 3, and I'm adding that to x cubed plus x squared minus x plus 7, that's going to result in x to the 4th plus x cubed plus 3x squared minus x plus 4. Going through the process of figuring out that degree, going to be the degree of the highest monomial term, which is the first one, degree 4 still. Okay, so even as we increase the complexity of each polynomial, we're not changing the degree of the result. Well, now what happens if both polynomials have the same degree? That's going to be a little bit tougher. If we start the same way that we started above, with two simple degree 4 polynomials, x to the 4th plus x to the 4th, that would be 2x to the 4th, which is degree 4. But just as simple would be x to the 4th plus negative x to the 4th, which combining those two like terms would be 0. Okay. Up above, we always wound up with degree 4. But now below, I looked at two different examples, pretty straightforward examples, and we got polynomials with two different degrees, degree 4 and degree 0. Well, that happened because the two degree 4 terms simplified, and they went away. Well, let's keep looking. What if I have x to the 4th plus x cubed as my first polynomial, and then plus negative x to the 4th as my other polynomial? Well, that's going to be x cubed, which is degree 3. So now, I first prompt you to figure out if you can come up with two examples that would give us a degree 2 and a degree 1. And the answer there is yes. I'll give you a few seconds to think about that. Okay, so the easiest thing would be just to take this example and put an x squared and an x here, and we would accomplish that. Okay, so what that means is if the 4th degree terms cancel out, which is possible, that means we have the potential to get any degree lower than 4. So that would mean degree 3, 2, 1, or 0 in this particular example. Okay, so degree can range from 0 to 4. So let's try to generalize this more. What if we had two degree 8 polynomials? Well, we can go through this same process and realize we could get a degree 8 result, or 7, 6, 5, 4, 3, 2, 1, all the way to 0.